Welcome to Moisayan Bar and Decoded. Today we're going to peel back the curtain on one deceptively simple and wildly powerful idea. There exists a neural switch that, when understood and engaged properly, can dramatically increase both motivation and discipline. The title for today is episode THC Sira 10 URL Soai THCSQIROS Kesmatavu Ioman Iskipsilayan. There's a point in every human life where motivation doesn't feel like a choice. It feels like something that switches on or off depending on the day, the task, or the emotional weight we carry. But when you look beneath that subjective experience and study what's happening in the nervous system, you find something far more structured, almost mechanical. There is a primary neural switch, but it's not a simple neuron or a simple on-off lever. It's a pattern, a coordinated activation across a set of circuits that, when engaged properly, acts like an ignition system. Once that ignition fires, the entire nervous system shifts into a mode where action feels possible, effort feels meaningful, and discipline feels less like force and more like flow. The core of that switch lies in the mesolimbic dopamine pathway, specifically the ventral tegmental area, or VTA, projecting to the nucleus accumbens. These neurons don't create pleasure, and they don't deliver motivation as a reward. What they actually do is encode what's known as incentive salience, the sense that something matters enough to move toward. When these dopamine neurons fire in quick, phasic bursts, they create a prediction signal. That signal says, there's something valuable ahead, move. It's that simple message that shifts your brain from passive observation into active pursuit. And it's not tied to the size of the reward, it's tied to the relative change, the prediction error. When reality exceeds expectation, dopamine spikes. When reality meets expectation, it steadies. When reality falls short, it drops. This calibration of prediction and outcome becomes the first stage in the ignition sequence. If your dopamine system is signaling that the outcome is worth pursuing, you feel the pull of motivation. But motivation alone doesn't guarantee action, because another system must evaluate, control, and direct that energy. That system is the prefrontal cortex. The prefrontal cortex is what gives you the ability to resist impulses, hold a goal in mind, and organize steps toward that goal. It's the rational overseer, the part of your brain that says, here's what we're doing and why we're doing it. When dopamine engages the nucleus accumbens, it essentially hands the baton to the prefrontal cortex, saying, we have incentive, now we need direction. If the prefrontal cortex is underactive, whether from fatigue, stress, sleep deprivation, or distraction, you can feel the desire to take action, but still fail to initiate. That's the moment when people say, I want to, but I just can't get myself to start. So this primary neural switch isn't only about motivation. It's about motivation being aligned with executive control. The dopamine system provides the spark, the prefrontal cortex channels it into structured, goal-oriented behavior. But there's still a third layer to this ignition process, the layer that determines whether you have the physiological arousal and focus needed to actually execute. That layer is the locus coeruleus norepinephrine system. If dopamine gives meaning and the prefrontal cortex provides direction, norepinephrine sets the intensity. It determines whether your brain is alert, ready, and able to sustain attention. Too little norepinephrine and everything feels dull, distant, or slow. Too much and you become overloaded, anxious, or scattered. The ideal state, the state where motivation and discipline can actually express themselves, occurs when the locus coeruleus is firing in a phasic pattern. This creates a narrow, high-resolution mental spotlight where distractions fall away and the desired action becomes the dominant behavioral path. When all three systems align, phasic dopamine for incentive, strong prefrontal activation for planning and inhibition, and balanced norepinephrine for optimal alertness, the switch flips. It's not willpower, it's neurobiology. What you experience as a sudden surge of readiness or determination is actually the synchronized activity of these circuits working in harmony. The beauty is that this switch is learnable and trainable. It responds to behavior. Small wins increase dopamine prediction accuracy. Clear planning activates the prefrontal cortex. Light exposure, breathwork, and brief movement tune the locus coeruleus into that ideal phasic mode. Over time, repetition shifts control to habit circuits in the dorsal striatum, meaning discipline becomes automatic rather than effortful. Understanding the primary neural switch that drives motivation and discipline means understanding the sequence, meaning direction, B intensity, get action. When one part is missing, the system fails. When all parts are aligned, it's astonishing how much you can accomplish with seemingly minimal effort. This isn't magic. It's the architecture of the brain doing what it was always designed to do: pursue what matters. Executive control is one of the most unique features of the human nervous system. It's the ability to override impulses, hold a goal in mind, and direct behavior towards something that may not feel rewarding in the moment, but pays off later. It's the biological foundation of discipline, not the motivational spark, not the emotional drive, but the steady, deliberate force that keeps you on a chosen path even when everything in you wants to deviate. And at the center of this capacity is the prefrontal cortex, the network of neural tissue behind the forehead that acts almost like the CEO of decision making. The prefrontal cortex doesn't create desire, it manages it. It doesn't generate motivation, it organizes and sustains it. What it truly excels at is shaping behavior over long time scales. That means coordinating sequences of actions, setting priorities, planning, suppressing distractions, and maintaining the representation of a goal, even in the face of competing urges. When people talk about discipline, consistency, or self-control, they're really describing the activity of the prefrontal cortex exerting top-down influence over older, more reflexive circuits deeper in the brain. This system, however, is energy-intensive. It requires metabolic resources, rest, and a certain level of physiological balance to function well. When people feel undisciplined, it's often not a character flaw, but a sign that the prefrontal cortex is being asked to do too much with too little internal support. Stress, sleep loss, emotional overload, and constant digital stimulation all degrade the functioning of these networks. The brain shifts into a mode where immediate impulses have the upper hand and long-term thinking gets pushed into the background. This is why discipline tends to collapse under chaotic conditions, not because you're weak, but because your neural circuitry is overwhelmed. Executive control works by modulating the limbic system, the emotional and motivational centers. These limbic circuits operate quickly, automatically, and sometimes impulsively. They want what feels good or familiar right now. The prefrontal cortex steps in like a stabilizer, saying, not that. This instead, it inhibits, redirects, or postpones actions. That inhibition is the core of discipline, the ability to say no, an immediate impulse in service of a longer-term aim. When the PFC is strong and well engaged, you feel clarity, direction, and a sense that your behavior aligns with your goals. When it's compromised, you feel pulled in multiple directions and unable to follow through. What's fascinating is that executive control is not fixed. These neural pathways can be strengthened, much like muscles. One of the most reliable ways to strengthen them is through repeated, deliberate practice of small acts of constraint and follow through. Every time you choose the task over the distraction, every time you complete a small commitment, you're reinforcing the circuitry that supports discipline. The prefrontal cortex thrives on repetition and specificity. Vague goals do little for it. Clear, time-bound goals energize it. Another key piece is that the PFC works best when the demands placed on it are clear and narrow. Trying to hold too many goals or tasks in mind overloads its working memory systems. That's why the most disciplined performers in any field simplify their processes dramatically: one task, one block of time, one immediate outcome. The nervous system performs exponentially better when the target is unambiguous. Physiological state also plays a major role. When you're in a high stress, high arousal state, limbic reactivity tends to overpower prefrontal regulation. When you're in a very low arousal or fatigued state, the PFC lacks the energy to maintain sustained control. The optimal state for discipline is a moderate arousal level, alert but not anxious, focused but not tense. Tools like controlled breathing, reducing sensory input, taking brief movement breaks, or adjusting light exposure can shift the autonomic state into this sweet spot, allowing executive circuits to function more effectively. There's also an important interplay between dopamine and executive control. Dopamine doesn't create discipline, but it increases the perceived value of the long-term outcome that the prefrontal cortex is trying to steer toward. When dopamine is aligned with a goal, the PFC has a much easier time maintaining effort. When dopamine is heavily attached to distractions, for example, through social media, novelty, or constant quick rewards, discipline becomes very difficult because the limbic system is being reinforced to seek immediate gratification. Ultimately, executive control is about creating internal order. It's about teaching the brain to prioritize what matters over what is merely stimulating. And the key to strengthening discipline is not heroic willpower, but consistent structure. A clear plan, a defined window of work, a single actionable step, an environment with fewer distractions. These are all ways of offloading some of the burden from the prefrontal cortex so it can do what it's designed to do. Keep you aligned with the person you want to become. Over time, with repetition and the right conditions, discipline becomes far less effortful. The actions you once had to push yourself to perform get transferred to deeper, more automatic circuits. That's when discipline stops feeling like restraint and starts feeling like identity. And it all begins with understanding and training the executive control systems that govern how you move through the world. Arousal and focus aren't abstract concepts. They're physiological states governed by a very real, very precise set of neural circuits, with the locus coeruleus and its release of norepinephrine at the center of the entire operation. When people say they can't focus, what they're often describing is a misalignment in this system. And when they say they're overstimulated, anxious, or mentally scattered, they're also describing a mismatch in the exact same circuitry. Understanding how arousal works isn't just interesting. It's the foundation for creating the internal conditions where motivation and discipline can actually take root. The locus coeruleus, a small structure in the brainstem, acts almost like a volume knob for your entire nervous system. It determines how much internal gain you have, how alert you feel, how intensely you direct your attention, and how ready you are to engage with a task. It releases norepinephrine, which signals various brain areas to increase their activity, sharpen their responsiveness, or, in some cases, suppress noise. When the locus coeruleus is firing too slowly, you drift, procrastinate, feel apathetic, or dissociate. When it fires too rapidly in a tonic pattern, you feel jittery, unfocused, overwhelmed, or stuck in a cycle of scanning for threats instead of taking action. The magic lies in the middle ephesic pattern, where bursts of norepinephrine sharpen attention precisely when you need to engage. This system evolved to help us deal with challenges that required precise timing and intense presence. Hunting, avoiding predators, scanning the environment for opportunities. In modern life, those challenges have been replaced by tasks that require concentration rather than physical vigilance. But the brain doesn't differentiate. It uses the same circuitry. When you sit down to work and your mind feels scattered, it's often because your internal arousal state doesn't match the demands of the task. You might be too relaxed or too activated. What we often call lack of focus is really a mismatch between cognitive demand and arousal level. One of the most important principles of neuroscience is the Yerkes-Dodson relationship. Performance increases with arousal up to a point, then drops off when arousal becomes too high. This applies to everything: studying, athletics, creative work, speaking, problem solving. You want to occupy that middle zone where you're alert but not anxious, energized but not frantic. And the beauty is that you can shift yourself into that zone using behavioral tools that directly modulate autonomic and brainstem circuits. Breathing is one of the most powerful tools. Slow, deliberate exhalations, longer than your inhales, activate parasympathetic pathways that reduce overall arousal. If you're overactivated, this can bring you down into a functional range. Conversely, a few sharp inhales followed by controlled exhales can increase activity in the locus coeruleus, giving you more alertness. Cold exposure, bright light, and even brief intense movement all increase norepinephrine levels in a way that heightens readiness. These aren't hacks, they're biological levers. Another key factor is sensory input. The locus coeruleus constantly monitors the environment. Too much input, noise, clutter, multiple screens, notifications, pushes it toward a state of high tonic firing, making focus nearly impossible. This is why reducing visual noise, silencing your phone, or isolating a single task quiets the system enough to engage phasic bursts. When the environment is simplified, the brain can selectively attend to what matters. There's also a strong link between arousal and emotional state. Stressful thoughts activate limbic circuits that elevate arousal. This can be useful in small amounts. A little stress can sharpen performance. But chronic or uncontrolled stress sends the locus coeruleus into persistent overactivation. When that happens, even small tasks feel overwhelming. Interventions like reframing a challenge, narrowing your focus, or setting micro goals help shift emotional tone and reduce unnecessary activation. The timing of your day matters as well. Norepinephrine and cortisol naturally peak early in the morning, creating a built-in window for focus, alertness, and disciplined work. As the day progresses, these levels drop and cognitive control becomes harder. Understanding your biological clock means you can place demanding tasks when your arousal system naturally supports them rather than fights them. Perhaps the most interesting part of this system is its relationship with dopamine. Dopamine provides motivation, the signal that something is worth doing. But without the right arousal state, dopamine can't convert intention into action. Too little arousal and motivation fizzles. Too much and motivation scatters. The two systems work together. Dopamine gives the why, norepinephrine creates the readiness, and the prefrontal cortex delivers the how. Ultimately, arousal and focus are about alignment. You're at your best when your internal state matches the demands of the moment. The goal isn't to be calm all the time or highly alert all the time. It's to have the ability to shift, to bring yourself into the zone where your brain is engaged, stable, and capable of sustained effort. When you learn to regulate arousal, discipline stops feeling like a battle and starts feeling like a natural extension of your biological state. Discipline isn't willpower alone, it's wiring. Flip the right switches, build the circuits, and your future self will do the heavy lifting for you. Thank you for watching Brain Decoded. Subscribe, hit the bell, and let's decode the brain together.